Our home, Earth, is a marvel of cosmic history, a blue jewel suspended in the vast expanse of space, teeming with life and wonder. But how did this extraordinary planet come to be? Today, we embark on a journey through time, tracing the incredible formation of Earth, from the birth of the solar system to the dynamic world we inhabit today. Our story begins around 4.6 billion years ago, in a vast, cold cloud of gas and dust, known as the Solar Nebula. This primordial cloud was the remnant of previous generations of stars that had exploded in supernovae, scattering elements across the cosmos. Gravity began to pull these particles together, creating a spinning disk of material. At the center of this spinning disk, matter began to coalesce, forming the early sun. Meanwhile, in the cooler outer regions of the disk, solid particles started to stick together, forming clumps known as planetesimals. These planetesimals were the building blocks of the planets. Through a process called accretion, these planetesimals collided and merged, gradually building larger bodies known as protoplanets. As these protoplanets continued to collide and grow, they began to take on the characteristics of the planets we know today. About 4.5 billion years ago, one of these protoplanets, which would become Earth, was a molten, violent world. The intense heat from constant collisions, radioactive decay, and the gravitational compression of the planet caused it to remain in a molten state. Then, a cataclysmic event known as the Giant Impact Hypothesis took place. A Mars-sized body, often referred to as Theia, collided with the early Earth. This collision was so immense that it caused a significant portion of Earth's outer layers and Theia to be ejected into orbit, eventually forming the Moon. Following this colossal impact, Earth began to cool. The molten surface gradually solidified, forming a primitive crust. As the planet's surface cooled further, volcanic outgassing created the early atmosphere, composed primarily of water vapor, carbon dioxide, and nitrogen. As Earth's surface continued to cool, water vapor in the atmosphere began to condense, leading to the formation of the first oceans. These primordial seas were essential for the development of life, providing a stable environment where the earliest forms of life could emerge. The exact timing of life's origin remains a topic of intense research, but evidence suggests that the earliest life forms appeared around 3.5 billion years ago. These microscopic organisms, known as prokaryotes, thrived in the nutrient-rich oceans and began to shape the planet's atmosphere and chemistry. One of the most profound changes in Earth's history was the Great Oxidation Event, occurring around 2.4 billion years ago. Photosynthetic microorganisms began to produce oxygen as a byproduct, dramatically altering the atmosphere and paving the way for more complex life forms to evolve. Over billions of years, Earth's surface continued to evolve. The movement of tectonic plates led to the formation and reformation of continents. About 335 million years ago, these land masses coalesced into a single supercontinent known as Pangaea, which eventually broke apart to form the continents we recognize today. Today, Earth is a dynamic and ever-changing world, characterized by its diverse ecosystems, complex climate systems, and rich geological history. From its fiery beginnings to the lush, life-filled planet we inhabit now, Earth's formation is a testament to the incredible forces of nature and the intricate processes that have shaped our world. As we gaze out at our planet from the vastness of space, we are reminded of our deep connection to the universe and the remarkable journey that has brought us to this moment. Understanding Earth's formation not only illuminates our past, but also inspires us to safeguard the future of this precious blue planet. Thank you for watching. Subscribe for more explorations into the wonders of our world.